Okay, so good morning everyone. What I'm going to show you today is how to take the axle twist that sometimes occurs on the Case garden tractor. And as an example, we're using one from one of my own restoration projects. Typically it is the right hand side that twists, and so it throws the spindles out and you end up with a camber in the spindle that you don't want. So what we're going to do is we're going to heat this up with propane in a forge that I built last year for decorative things such as horseshoes and wrought iron, that sort of thing. So I've been able to get some substantial heat out of this, and this will be my first time to find out whether it works here. I think it will. The tank that I'm using is just a normal 20-pound tank with a 30-pound regulator on it, not typically found on a gas grill, so you would have to order that regulator from Amazon, where I did, or some other place. And then what that does is it feeds through a homemade burner. There is a MIG welding tip, an 035 thousandths welding tip that I fashioned inside of a pipe coupling and a pipe plug. It shoots the gas down into a long pipe, which becomes your mixing chamber, and then the exit flame comes in here surrounded by fire brick. So fortunately this is going to enable me to get the axle inside. I got just enough room to do that with some flexibility. And before I do this, I just point out to you that the twist occurs from this point down, because everything up here is captivated by the tractor frame. So all of the twist is down in here. So this is where we want to concentrate the heat. And once we bring it up to a straw colored orange, what we'll do, and I'll show you in a later clip, is I'm going to set this in a vise and then I'm going to reef it with a pry bar. So with that, I'm going to get set up here and get everything fired up. I'll show you a little bit of the flame, how that's impacting the heat process here, because we have to remember this is a long piece and the heat is going to migrate outwards, so we're going to have to focus it. This will provide more control than a torch would, so we're going to keep everything surrounded and try to bring up the affected area with a concentrated heat, and then run quickly to the vise and then pry it. Now, assuming I'm successful, which I will be, the point is once you get the spindles so that they're coplanar, which means they're both in the same parallel to each other, then the next step would be to return the axle to the fire, because since you've twisted it, you have some upset to the molecular structure in this cast piece. So what we want to do is reheat it, maybe not quite as hot, but just enough to allow the molecules to settle down and take a set. Alright, so with that I'm going to get set up, and I'll be back to you shortly. try to talk above this noise, but if you take a look in there, and if I can get a good shot of it, you can see that just after a couple minutes of runtime, that we're really bringing the casting up to heat. I said straw orange earlier. I'm sure we're going to be hotter than that, but we don't want to be any cooler than that. This is really doing a very great job in a very short time. It's almost mesmerizing, isn't it? So I'm going to put the thermometer on, or the laser gun on that, just to see how hot it is. Wow, that's really coming up nice. Yeah, I'm way over the scale on the laser thermometer now, which is over 1,000. And as you can see, wow, look at how hot that baby's getting. So I'm going to pull it out a little bit just to position it a little better. Spread some of this heat out. I can see that I'm catching the portions of the I-beam. So I want to get out a little more on the end. It's kind of hard to do when I'm trying to do two things at once here. That smoke is just the grease burning off. Okay, so I'm going to do a little more repositioning and be back soon. Okay, so there you have it. It's back where it belongs. And I got lucky on the first try. I gave it a couple of wreaths, as you noticed. One thing I forgot to point out to you is the span in question was this one right here. If you notice, this side burned too. I actually preheated that. I was picking up about 700 degrees, so I didn't want to lose all of the heat focus here, so I wanted to just bring this up to speed a little bit so that the distribution wouldn't chase all the way over to this other side. So given that, if you'd watched me, I don't know if you could see it or not, but it actually came back pretty easy. Took a little bit of effort, but with an 18-inch pry bar, it wasn't any big deal. But everything's straight now, so what I'm going to do is I'm going to put this back in the fire and just heat this one side, and then let the grain structure readjust itself and settle down, and then it'll just cool out here in the air. Okay, here's the finished product. Brushed it up a little bit, get some of the oxidation off, but as a check on the work, you can see that the left side is now squared up, and it is coplanar or parallel with the other side. I know it's going to be hard to show that here, but I'd like to wrap this up with another segment here, and still a little warm but not bad. So here's the deal. Okay, what I've done is beefed up the front a little bit with these bearing spacers that I got from Tractor Supply. They're 1.5" ID to match the pin. The old pin, I'm just not going to use it, so I like this setup better. If you look down in here, what I do is I drill out and tap an extra hole so I can have 2 set screws at the bottom on both sides to retain the whole assembly, and then the pin will go in as such to create a little more stiffness perhaps in the whole thing. So noting the pin, this is some 1.5" round bar stock. I got it at a place called Alro Steel. They're through the Midwest, ALRO Steel. You can go to their website. I bought a 3-foot length of this stuff for $10, I believe it was. So what I've done is I've modified the pin, and very roughly I cut a central annulus or circumferential groove to create a grease track, and then put some marks in with an angle grinder to create some grooves so that it'll carry that grease out where it belongs, because you know most of it will probably just gush out, so this will help spread it out a little bit. And then when we get all done, we'll put all this back together and have a nice robust setup. It's probably a little bit more overkill than what some of the guys on the Case website offer for pin upgrades. I've seen different kinds. This is just my preference. So the other thing that we have to do yet, because Case economized with grease fittings, they used press-in fittings into pre-drilled holes. So what we'll have to do there is drill and tap for 1/8 inch and put a grease circ there. Same thing here. I'll replace both of these out here on the outer spindles, and so that should complete it. It's all in great shape. Love how it turned out. It didn't take a lot of work, which I didn't think it would, and it's really, when you heat it up, guys, you get a better distribution when you go to bend this back. As I say, you only need to heat from here to here, and all of this part here is already square, so that when this had originally been bent by dropping into a hole or running into a curb, there was nothing holding this outer end. So that's where the twist occurred. So if you keep your heat right in here, the problem you're going to have with a torch, you're just not going to be able to keep up with it, because you need that blanket of hot air in a forge around it to keep everything warm. And as I say, I did preheat the rest of this because I knew that this was going to go very quickly across here and I wouldn't have much time to get this fixtured up into the vise. So I hope that's helped you. Feel free to comment down below in my section if you have any questions. Just keep them nice. I like productive questions, and hopefully we'll see you soon on another project. And for now, that's all we have. Thanks again for watching. Take care. Stay safe.